Good evening, fellow preppers. Welcome to Off-Grid 12-volt solar prepping. In this video, we'll be seeing what's the difference between series and parallel wiring. Some people prefer series, some prefer parallel. Okay, when you're dealing with series, the watts get added up, the amps stay the same. When you're wiring in parallel, the amps add up and the watts stay the same. Whichever is your preference is up to you. But we're going to see the pros and cons for both. All right? Okay. First, we're going to do series. When you're wiring series, you take the positive and the negative and you connect them together. Okay? Then you take the positive and you connect it to your charge controller. You take the negative and you connect it to your charge controller. Okay, that's the connection. That's the connection for series. Okay, now as you can see, in series, the positive is to the positive, the negative is to the negative. I always have the breaker off. I put the breaker on. There shouldn't be, even though the panels are sitting out of the sun, there's still some light shining on them. Right there in the corner, it's a little bit of light, but I doubt if it's enough to turn on the charge controller. But you'll never know. Let's see. Okay, lo and behold, it's trying to charge the charge controller. The charge controller is kicking on. That's incredible. It is kicking on. But this video is not about that. This video is just showing the differences between series and parallel connections. Okay, once again, in series, the amps stay the same, the watts are added. In parallel, the amps are added and the watts stay the same. Okay? I'm going to turn this breaker back off because we don't want to get shocked. There's current going through here, even though it's a small amount. Okay, it's off. Now we're safe to work with the wires. Don't have to worry about no surprise current popping us. Okay? Don't have to worry about that. All right. So, this is series. Once again, series, the watts are added. So this is a 200 watt panel, 200 watt panel. So this is 400 watts now. The amps are 8.5 amps, 8.5 amps. That stays the same. Okay? So we have 200, 200, 400. We have 8.5, 8.5, and it stays 8.5. They do not add up. Now we're going to do parallel. But just get this sucker disconnected. Sometimes they can be a little hard to get it loose. Okay, that was a little tough one there. All right. Okay. Now, when you're dealing in parallel, you have to have these connections. You must buy these connections because you cannot connect a positive to a positive. It ain't gonna work. You can't connect two males together. It doesn't work. Male and female go together, not male and male, or female and female. So you have to buy these to make the connection work. All right. Putting them in. Okay. Negative. Negative. Positive. Negative. Positive. And on the other end, it's negative again. All right. Black wire. Negative. Okay. Now, two positives. On this end, we have females. One, two. Okay, even though it's red and it's female, it's positive because this is how it has to change up for this. So don't let it confuse you. It's still positive, red wire. Okay, this is your parallel connection. In this setup, your amps are added. You have 8.5 amps, 8.5 amps. That makes 17. Now we have 17 amps. Each panel is 200 watts. They do not add up. They stay 200 watts. In parallel, only the amps add up. So 8.5, 8.5, 17 amps. Okay. Now, the importance that you have to remember with that is your solar panel wiring is a special kind of wiring. You can use Timco, I use Grady. But Timco or Grady is very good solar panel wiring. These wires are PV grade. These wires are much more firm. They don't bend as easy as the regular silicone wires. Okay? These wires aren't nowhere near as flexible as these. You see these? These are the silicone, the regular silicone wires. These are not flexible. These wires have a much more tough insulation. These wires, you can leave them in the sun, no problem. Put them underground, no problem. Leave them in the rain, the snow, the sleet, the hail, no problem. They'll last for many, many, many years. If you did that with these silicone wires, don't mind that. Those are just speedboats out there and jet skis. Don't pay it no mind. They're just having fun. If you left these silicone wires out in the sun, they would degrade, I guess, in about a year. They would last like a season or two and start degrading, and you'd have shorts. These wires, you won't have that problem. So you have to always make sure that you're buying PV wiring for your solar panel, PV grade wiring for your solar panels, always. And if you're wiring in parallel, you're going to have to get a heavier gauge wire. 10 and 8 is the normal gauge for solar panels. But if you have like 4, 6, 8 solar panels and you're wiring them in parallel, those amps add up quick. 8 gauge solar panels, no, I'm sorry, not 8, 10 gauge wiring can handle, I forgot, I'm not good at this, but 10 gauge wiring is I don't want to say the wrong things. I'm not even gonna quote it. But you're good. You're good. I'll look it up for you in a minute. I'll give you the wiring when I take a break. Then I'll tell you what the gauges are and the amps they can hold. Okay. So now, what did I say? When you're wiring in parallel, only the amps are added. These panels have 8.5 amps each. So that's going to be 17 amps together. That's running through these cables. 200 watts, not 400, because the watts stay the same. Okay? Now, when you're wiring in series, you have two 200-watt panels. The 200 watts would be added up, and it would be 400 watts. The amps would stay the same. You would have 8.5 amps, and that's it, 8.5 amps. So let's say you had 4 200-watt panels. You would have 800 watts. And each panel has 8.5 amps. But they would not add up. It would stay 8.5 amps, which means that you would still be able to use these cables. Even though you have 800 watts, it's not the watts that give the electricity that punch. It's the amps that do it. Okay? So the amps stay the same when you're using series. And these wires are much cheaper than buying big, thick, heavy gauge wires when you're using a heavier amperage. And we all want to save money. The power output is going to be the same. All right? Any questions, you could just write me in the comments and I'll answer you back in less than a couple of hours or sooner. All right? Now, I'm going to take a break so that I can get that information for you and see what it is. All right. Be back with you in a second. Okay, as you can see, wire section short. All right. Now, this is called Circuit Wizard. As you can see, 8-gauge wire from critical 10 feet, non-critical 30 feet. This is a non-critical setting. So as long as you don't go over 30 feet, you can use an 8-gauge wire with 40 amps. Or you can use a 10-gauge wire with 30 amps. You see the example at the top of this diagram. The 10 gauge is green and the 8 gauge is blue. Okay? And that's how this works. Because when you go further than 30 feet, you will drop off in power. The wire will lose wattage. So you'd have to get a heavier wire if you want to go further than 30 feet. But that's another video, and we'll talk about that at another time. Okay, so I just wanted to show you this. Okay, so now you have it, and you can look at it. Okay, that's all for today. Thank you for viewing my video. If you learned anything and enjoyed this, subscribe and give me a thumbs up. Many more interesting topics to go. Have a pleasant day, and until next time, bye-bye.